and we put 0, -8, and 4 on our number line, and we're going to shade including -8 and to the left, and including 4 and to the right is x is less than or equal to -8, or x is greater than or equal to 4. So we've given the number line. Okay, in number 4, we have a cubic. We have a degree 3 polynomial, which means that our graph can cross the x-axis up to 3 times. Okay, so that's a clue there as to how many times we could get zeros. So let's see what happens. Well, once again, we're going to solve this for, set it equal to 0 is the way you say that. Make this a 0 by adding 2 to both sides, ending up with x to the 3 minus 3x squared plus 2 is greater than or equal to 0. Okay, so now let's see what happens if we graph that. So I'm going to clear this function, whoops, go up there and clear, and put in x. Now, to get the exponent is this caret to the 3rd power. There's x to the 3rd power. Minus 3x, so there's minus 3x plus 2, plus 2. Okay, and we'll graph that. Beautiful. Okay, so let's see what happens here. So we have our function, we have our graph, and I feel like something is wrong with this. I can see it. Look what I did. I forgot to put in 3x squared. Okay, well, I'm glad I made that mistake because I can now show you how to insert if you make a mistake. Rather than having to retype the whole thing, we're going to insert by moving my cursor over here and go second insert, and I'm going to raise this to the 2nd power. See what had happened there? Okay, so now let's see what happens. This is more like what I was looking for. There it is. Okay, so we have, clearly we have 3 roots. We have 1, 2, 3 roots. Okay, and where is this function positive? Greater than 0, it's positive in here. This is positive, and here. Over here it's negative, and here it's negative. So isn't it true that this is positive and this is positive? And so I'd like to know, what are they? Now, you might look at that and go, it looks like it could be -1. Let's look at our table and see if it is at -1. Well, at -1, when x is -1, y is -2, I don't think then that that's, a 0, right? So somewhere between 0 and -1 is our 0, or where it crosses the x-axis. And you can kind of see it's not quite to -1. Because at -1, it's actually negative, the function is -2. So do you remember how you find that? You're going to look for zeros. You're going to go second calc 0, which is number 2. Okay, and now you have to tell it, well, I'd like you to look, please, calculator, in here. And so your left boundary is over here, and your right boundary is over here. I am on the y1. Okay, I don't have more than one function in my calculator right now. So I'm scrolling with my left-hand arrow to get the cursor over here. I'm going to enter that. And now I'm going to scroll with my right arrow to come up over here to find out where is that. And I'm going to then guess, because it might not be a rational or whole number. Okay, so it looks like we have a 0 at when x is -0.73. We'll just use that. Okay, so x is approximately equal to -0.73. You can put a 0 in there. It's not a bad idea. Okay, whoops, I'm on the wrong equation here. X is approximately -0.73. Okay, now, what does that tell us? That just tells us what this is right here. What's this over here? Maybe it's a 1. Let's look at our table. At 1, oh cool, at 1, y is 0. Okay, so we don't have to do any more work for that. We have at x equals 1, we have a 0. And where's the other 0? Well, it looks like it could be over here. It could be 1, 2, 3. I'm going to look at my table. Second table, is it at 3? No. At 3, it's 2. At 2, it's negative 2. So somewhere between here and here, it goes from being negative to positive. So it's somewhere between 2 and 3. I am going to have to use my second calc 0 function on the calculator and ask my calculator to find. So now I'm scrolling over here because this is the one I don't know about. I'm scrolling over here to say, please calculator, look in here, enter that, move above to the positive, enter that. Do I guess? Yes, please. Okay, so clearly it's between 2 and 3 when x is approximately equal to 2.73. Okay, so let's see if we can sketch this. We have a 0 at negative 0.73, which is right next to negative 1. And we have a 0 at 1. And don't make them too big, but enough where you can see them. And another one at 2.73. So 1, 2, 3, it's right about here. Okay, now another thing we can do is say, like, what is this? What is the y-intercept? Remember what the y-intercept is. The y-intercept is when x is 0. So if x is 0, this is 0, this is 0, y-intercept is 2. Okay, so that's handy. So we know that when x is 0, y is 2. And of course, when we look at our picture, that looks like a maximum right there, so that's kind of handy. What about this point right here? At 2, maybe I'm going to look for, in my table, at 2, it's negative 2. So 1, 2 is negative 2. That appears to be a minimum. Okay, so I'm going to kind of sketch this picture. I want to make it look curvy. Cross at 1, cross at 2.7, cross at negative 0.7. Okay, and hopefully that looks something like this picture. So I drew an arrow here, you know, my picture continues on and my picture continues on, and I drew an arrow here, meaning that continues. But all my crucial points are here, 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 and here. Okay, now let's get to what we have to do here. The solution set. X is between negative 0.73 and 1, the y function is positive. So I want to say the set of all x's such that between negative 0.73 and 1, and it's inclusive because we have a equal sign there, or, but instead of or, I'm going to put the v, and that's a symbol. X is greater than or equal to 2.73. Okay, so that's written in set notation. Now let's see if we can just sketch it on our number line. Here's 0, here's negative 1, so 0.73, negative 0.73 is about there. And then we have 1, 2, 3, there's 3, and we're at 2.7, something like that. So between negative 0.73 and 1, I'm positive. See, I'm above the x-axis there. So I shade between there. And then from positive 2 73/100 and above, that will always be positive. That's never going to come back down. How do I know it's not going to come back down way over here? How do I know? Well, it is a degree 3 polynomial, and I have 1, 2, 3 roots, so there cannot be another one. I also know the shape of a degree 3 polynomial is such that it comes from below and goes up indefinitely. So I know based on the shape and the fact that it's a degree 3 polynomial that it will not come back down eventually. Okay, so here's